Alright, so now I have another relay that was in one of my kits, so I figure I'll cover that. I'll put the name of the relay in the title. And in any case, this one's a latching relay, which is really nice. So let's see, I got a resistor there. It might be that one there. Okay, the resistor's not going to work. So sometimes it works with the resistor, but it always works with this. So I don't think you need a resistor to protect the coil at all. But there you can see that using the relay, it's a mechanical switch that's electrically controlled, and this one's latching, so it latches in one of two positions. So now there's 5 pins on each side. I had to go find the data sheet to figure this out, but it is polarized, the control here, so I think I have the layout right. This side needs to be more negative, and then this side there's 2 pins that you connect to the more positive side of the power source. This is only rated for 5 volts though. The breadboard here is outputting 5 volts right now because I have the pins there. We can turn the power supply off, move the jumpers. This will give us 3.3 volts, and it seems to work just fine with 3.3 volts too. And of course you can build the circuit on the other side of the relay there too. The pins are on both sides. Let's turn the power supply off. It's best to turn off the power supply before you modify any circuit, but there you can see we have 2 pins. That's where the positive comes, and then of course there's matching pins on the other side. So positive over here, negative over there, as long as I understand the data sheet correctly. And it's working, so I'm assuming I did. And then center pin, we have, in this case, polarity doesn't matter there, I don't think, because it's an AC relay. So up to 1 amp, 125 volts AC. And of course, if you're using voltage that high, you don't want to be able to touch anything conductive of that. So I'm not going to do any of that. But it can also do 2 amps at 30 volts DC, according to that. So in any case, we got one side of the switch there, and it either connects to that one, or it connects to that one, depending on which pin got the positive pulse, and then it latches in place. So positive comes to those pins, so you can see that the long lead of these LEDs, the anode, is where the pin will be, and then the cathode, the short lead, comes to this jumper, which goes to ground to complete the circuit from positive to negative. So this is really nice because you don't need to use any. Also, I should mention that it doesn't really go into the board terribly well at all times. You gotta kind of push it and stuff. So sometimes it feels like it's in the board good, but it's not. But in any case, it latches in place, so it's really nice. We are at 3.3 volts right now, and that LED looks a little dim. We're using 220 ohms of resistance, which is a plenty of resistance, or about almost the minimum resistance you want. Need to turn this supply on. See, you can see that it's much brighter now. Well, another thing of note is that each side is independent. So there you can see that right now that LED is turning on and off, whereas that one's just staying off even though it's in straight across from there. But if I move the resistor over there and I plug it into the other pin, there we go. Now you can see we can switch that one. So they're both independent switches. There's actually 2 switches on here being controlled by that. They're single pole, double throw. And again, let's try the 100 ohm resistor at 5 volts. It doesn't work at 3.3 volts, but right now I'm switching it okay with the 100 ohm resistor. So I don't know if I was doing the wrong pin earlier or what, or if sometimes it won't switch with resistance. But in any case, that's 100 ohms, works at 5 volts, when I put it at 3.3 volts, it never switches.